So this is Simultaneous Equations practice. These are the 4 questions which you can have a go at now. I'm going to go through them in a few seconds. Also, I've already had a go at it, but I didn't explain it very well, so I'm just having a second go. It's okay to get things wrong the first time. Okay, ready? Okay, so we have this. And we want our final result is going to look like A equals something and B equals something. That's the point. Okay? So we have to get from something that looks like this to something that looks like that. And the first thing you notice is this has an A and a B on it. This only has an A. Okay? There's not going to be any B's or A's on this side. We just want a single A on one side. So we have to get rid of that B first. How are we going to do that? Well, we have 2 methods of doing it that I mentioned on the last page. I call it substitution, or I call it subtraction over there, but I think I'd rather call it cancellation. It's when you cancel one of these two, but I'll show you in the next thing. So, which one should we use here? Substitution or cancellation or subtraction? Right, subtraction also makes sense. Okay, well, it's already in the form of A equals B plus 1. That's a good hint to go towards substitution, because half our job is already done. Because we're just going to sub B plus 1 equals A into our original equation. So let's do that now. 1. Sub A equals B plus 1 into 1. I didn't need to write that 1 there. And if we sub it in, now A becomes B plus 1. We get 4 B plus 1 plus B equals 14. Well, here, if we expand that, 4b plus 4 plus b equals 14. Therefore, we add the b's together. 4b plus b equals 5b equals 14 subtract 4 equals 10. Therefore, b equals 2. And if we sub b equals 2 into 2, if b is 2, a is obviously 3. So that's how substitution works. So let's see what this will give us. 4 equals minus 2m plus c, minus 2 equals 3m plus c. I can't see anything clear to substitute. It's a little bit difficult. We could probably do it with the first one, but we notice that the number in front of c is exactly the same. There's a hidden 1 here. Okay, it's 1c, 1c. So if we subtract them off each other, we should be able to get rid of it. And that's our aim. So let's do it here. I'm going to do 2 subtract 1. You could do 1 subtract 2, but I like using the bigger number to subtract the smaller number. So minus 2 equals 3m plus c, and 1 is 4 equals minus m plus c. Okay? So let's subtract them. Minus 2 minus 4 equals minus 6. 3m minus m, so it becomes 3m plus m equals 4m. And c minus c equals 0, 0c. So we know minus 6 equals 4m. Therefore, m equals minus 6 on 4. And for those of you who want to simplify, we can cancel the 2's out and it becomes minus 3 on 2. Okay? Minus 6 on 4 is, that's 2 times 3, and that's 2 times 2. So we can cancel the 2's. Minus 3 on 2. Now we just need to sub it back in to 1. 1 now implies 4 equals, we know m is minus 3 on 2. So minus m becomes 3 on 2 plus c. So c equals 4 minus 3 on 2, because we took the 3 on 2 over, equals, to subtract, we need to get the same number on the bottom. So I converted that to 8 on 2, and that equals 5 on 2. So that's a good example of I'm going to call it cancellation. So I'm going to try and speed things up. Here's another question. You guys can try that. We're just using y's and x's. It doesn't really matter. Okay, what do you think we want to do? Substitution makes perfect sense. Because we know y equals this, and y equals that. We can just make them equal each other. So now 2x minus 2x plus 5 equals 4x minus 1. We'll take the 2x's to what do you do here? Remember, we always want our solution to look like x equals something. So that's all the x's on one side. we need to get all the x's on one side first and get everything else on the other side. So 5, we bring the 1 over, plus 1 equals 4x, bring the 2x over, minus 2x. 6 equals 2x. Now the 2 is in the way, so I need to get rid of the 2. X equals 6 on 2, which equals 3. X is 3. Now what's 5? Sub it back into our original equation. Let's call that 1. Sub into 1. And we get y equals 2 times 3, because x is now 3, plus 5 equals 6 plus 5 equals 11. X equals 3, y equals 11. We just solved it. And my final question, here's 3 equations. So remember, simultaneous equations is multiple at the same time. 3 is still fair game. How would you do this? Well, we can look at these 3 and think about what we really want is A equals something, B equals something, C equals something. And we could work with the first equation, but there's so many letters in that. That's too hard. I'm a lazy guy. I only have time to work with these things first. This will be the easiest. And can you see some way to get rid of A or B? I can. I think if we subtract it, 2 subtract 3 gives us A plus 2B equals 8. A plus B equals 6. Subtract them, A minus A equals 0, plus 2B minus B equals B, plus 8 minus 6 equals 2. Okay? And the reason we can subtract equations is because like left hand minus 2 fingers equals right hand minus 2 fingers. I hope that makes sense, but it's like these two are equal, so we subtract something equal from both sides. We're still left with something. So B equals 2. A plus B equals 6. We sub into 3. Therefore A equals 4. A equals 4. Okay? And now we know A and B. We can sub it back into our original equation, our first one. Sub A equals 4, B equals 2 into 1. And we get A is 4. 2 times 4 plus 2 plus C equals 11. Or 8 plus 2 plus C equals 11. And we can easily see C equals 11 minus 8 minus 2 equals 1. And we've solved it. Okay? It's not too difficult. Simultaneous equations. Substitution, cancellation. You don't even need to remember the names of these or anything. Just know how to do it. Okay? Cheers, guys.